All right, so we're going to calculate the value of delta H for a combustion reaction based on the calorimetry experiment that you see here. So we're talking about the molar enthalpy of combustion of ethanol, and we have an aluminum can as a calorimeter. We have the combustion of liquid ethanol and the reaction that you see there. And then we have all of this data that we're going to use to calculate the value of delta H. So in a calorimetry experiment, we're going to compare the energy absorbed by the water and the energy released by the reaction with delta E equals negative delta E. On the left, we'll have our calorimeter, which includes both the water and the aluminum can in the calorimeter. And on the right, we'll have the values for ethanol. So we will have MC delta T for the water and MC delta T for the aluminum. And on this side, the number of moles and the molar enthalpy of combustion of ethanol. And for the number of moles, we won't have that value directly. We will need to use the mass and the molar mass of ethanol in order to calculate that. So we'll fill all of these values in. So for the water, the mass is 250.00 grams, like shown here. The value of C for water is 4.19 joules per gram degrees Celsius. And the delta T we can find over here doing the final minus initial temperature. So our final temperature is 82.3 and our initial temperature is 21.4. That leaves us with 60.9 as our delta T. For the aluminum values, it tells us up here that we have 10.65 grams of aluminum. The C for aluminum, the heat capacity is 0.897 joules per gram degrees Celsius, and the delta T is 60.9 degrees Celsius. On the other side, where we have the number of moles, which will be really represented by the mass and molar mass, we're going to take a look at the initial and final mass of the ethanol burner, and we'll see that the difference between these two values, 256.34 and 252.45, is 3.89 grams. So we'll do that, and we'll divide it by the molar mass of ethanol, which is 46.08 grams per mole. And then the last unknown is the molar enthalpy of combustion. So we'll perform these calculations and rearrange to solve for the molar enthalpy of combustion. So if we continue, we're still trying to calculate the student's experimental molar enthalpy of combustion of ethanol. We have a value that's in joules per mole. The question didn't tell us which unit we should give, but it's fairly probable that you'd be asked for kilojoules to mole, so we'll just go ahead and switch our answer into kilojoules. Now we have the student's experimental molar enthalpy of combustion.